Hello, good people. Welcome to video number 1 of section 7.6 and 7.7. We're still talking about differential equations. In the previous set of videos, we talked about solving differential equations by using slope fields to estimate what the solution curve would look like. So it was a graphical way of solving a differential equation. In this set of videos, we're going to talk about how to solve differential equations by actually finding the original function that produced a differential equation that we're starting with. So we're going backwards, if you will. Um, so here's what we need to know. A differential equation is an equation for the derivative of y in terms of x and y or other variables. The big idea here is that differential equations are when you are given the derivative of a function. Now, which derivative are you given? It doesn't matter. But as long as you're given the derivative function. So for example, here is a differential equation. I'm given the derivative of y with respect to x, dy dx, and it equals 2xy. So my derivative is in terms of my x and my y. Here's another derivative. Dy dx is equal to sine x over 3 minus y to the 2/3. Here's another derivative. This looks very simplistic. Dy dx is equal to y. Here's another derivative. dh dt is equal to 2h over t squared. That's a differential equation because it involves a derivative of the function. Y prime is equal to y squared over the natural log of x, another differential equation. So differential equations by themselves actually can create their own course, their own math course. There is a math course called differential equations and how to solve them. But on the AP exam, you could be asked to do one of these things. We already talked about how you could be asked to sketch a slope field, or you could be asked to sketch a solution curve given the slope field. You could be asked to write an equation of the tangent line of the original function given the differential equation, the derivative function. You could be asked to find the second derivative given the first derivative. You could be asked to determine the relative extrema at a given point, or find the horizontal or vertical tangent lines, or find the general or particular solution to a differential equation. So this is what we're going to focus on, is finding general and particular solutions of the differential equation. So how this works is you will be given a differential equation, dy dx, then y would be the original function. That's the solution to the differential equation. So you need to remember that whenever you're given differential equations and you're asked to solve them, the solution is the y equation that produced that differential equation, that dy dx equation. So this means given dy dx, the derivative, we need to find y, the original function. This is going to require us to do integration because if you're starting with a derivative and you want to find the function before the original function, then we have to take the antiderivative. We have to do integration. But we have to do some work on the derivatives involving both x's and y's. So in this course, there's many different types of differential equations. The only differential equations you're going to be asked to solve will be separable. And what that means, you'll find out shortly, is that we're going to be able to separate my x variables to one side of the equal sign and my y variables to the other side of the equal sign. So we'll be able to separate the dx and the dy through only multiplication. And you're going to see that in example 1 right now. I have a differential equation. Notice that this is a differential equation in terms of x and y, and we are asked to separate the variables. So how do we separate the variables? Well, we're going to multiply one side by dx, but if I do it to that side, I got to do it to the other. So over here, I'm writing down the original function in black, and I'm writing down the dx that I'm going to multiply on both sides. If I multiply by dx, my dx are going to reduce, and I'm left with dy. Here I'm left with 2x times y plus 3 times dx. But notice, on this side I have x variables and I have y variables. So I'm going to divide both sides by y plus 3. And when I do that, I have now successfully separated the variables. I started here, and now I have separated all my y's on one side and all my x's on the other side. I have separated the variables on either side of the equal sign. And this is going to be the first step in trying to solve differential equations. We're going to multiply both sides of the equation by dx. We're going to separate the variables by multiplying and dividing if necessary. We're going to try to put dy or y's on the left and x's on the right. We're going to integrate both sides. And then we're going to use the initial condition to find the constants of integration. And then finally, we're going to solve our final equation for y, get y by itself. That's the goal. Okay. I used to have a coworker that used to say, oh, solving differential equations was pretty easy. Just separate and integrate. And all that means is we're going to put all the x's on one side, all the y's on the other. That's step number one. Number two, we're going to integrate. We're going to take the antiderivative of both sides. That's going to give us what's called a general solution. And then if we want to find a specific particular solution, then we're going to use an initial condition, and we're going to see that in the next example, to find the constant of integration and find a complete particular solution. We'll come back in video 2 and we'll tackle this idea with example number 2.